evening, Algebra 2. Today we're going to be discussing section 3.3, which is graphing systems of linear inequalities. Alright? So, the first thing that we're going to do today is take an example of a system of linear inequalities. A good example would be x plus y is less than or equal to 8, and 4x minus y is greater than 6. These two paired together give us our system of linear inequalities. Now, a solution to a system such as this one is an ordered pair, like the ordered pair in this one, 2, 1. When we plug this into both equations, we find that it works for both of these inequalities, both of the inequalities. However, if we want to know all the solutions to any system of inequalities, we need to graph those. We need to graph them because in these situations we're going to have a lot more answers than just one answer like you had when you were graphing the systems of linear equations. So let's take a look at a key concept that is going to really help us out with solving these systems. Alright, the first step in this key concept is to graph each inequality in the system. You may want to use a colored pencil to distinguish between the two graphs so that we can see both sides of the shaded area. Remember that with inequalities, or when you have an inequality sign, we need to be checking two things, and that's if it's a dashed or solid line, and also which side of that line do we shade. Now, the second step of this concept is to identify the region that is in common to the graphs of the system. This is where the two colors will be mixed on your graph. Alright? They will be mixed. So, that's all you're doing when you're graphing a system of linear inequalities, is two steps. Graph the inequalities and then notice where the shaded region is, the combined shaded region. Let's go ahead and take a look at an example of this now. Alright, the first example we have is to graph y is greater than negative 2x minus 1 and y is less than or equal to x plus 2. So, when we do this, we want to keep in our key concept in mind. So step one, we're going to graph both of these inequalities. To graph this, I'm going to graph it like a normal line. I'm going to find my y-intercept, which is this negative 1 right here. So I'm going to make a point right on negative 1. Then I just follow my slope. My slope for this one happens to be negative 2 over 1. So I'm going to go down 2 over 1 to get this point at 1, negative 3. I can also go up 2 and back 1. Now, since this is an inequality, I'm going to want to ask myself, is it a dotted line or is it a solid line? And I notice right here, with this inequality, I'm dealing with just a greater than, so it's going to be a dotted line. I'm going to try and draw this line as straight as I can. And I make sure to add my arrows on both ends of that so we can see. Now, I ask myself the next question when graphing an inequality, and that's which side to shade. So I need to test a point. I'm going to go ahead and test the point 0, 0 right here. It's nice and easy. I plug 0 in for y, I get 0. I have a greater than. When I plug 0 in for x, I get negative 2 times 0, which is 0, minus 1, which is negative 1. As we can see, 0 is obviously greater than negative 1, so I know to shade this region up here with my nice red ink. Now, like I said, you may want to use a colored pencil, so I'm going to go ahead and switch this second equation to a nice blue for us so we can distinguish between the two. Now when I'm graphing this, again, I just find my y-intercept. I go ahead and mark my y-intercept, which is right here at positive 2. Then I check my slope. With this slope, I end up with 1 over 1. Nice easy slope. I go up 1 over 1, up 1 over 1. I can also go down 1, back 1, down 1, back 1. And then I just draw my line straight through there, as straight as we can go. Make sure on your homework assignments and the work you do in class you're trying to use a straight edge. Now, it was a solid line because I had an equal to right in that inequality. So The next question we're asking ourselves is, which side of the line do I gotta shade? Let's test the point 0, 0 again. Plug 0 in for y, I get 0. Plug 0 in for x, I get 0 plus 2 is 2. Is this a true statement? Is 0 less than or equal to 2? The answer is yes, so I know I'm shading down in this region. Down, everything down in here. Yeah! Uh-oh. Now that we have this, we need to notice that I have this shaded region. I'm going to go ahead and change color so I can really highlight this, and I'm going to use it with green. I have this common shaded region right in here. What this means is that any point within this area right in here is a solution. So as we've seen, the point 0, 0 is a solution for both of these inequalities. Both of the inequalities. So occasionally you will be asked to give one solution to this system of inequalities. Give one or maybe two solutions to this inequality. All you have to do is pick any point within this double shaded region, alright, in my green region over here. That means that one solution might be 0, 0. Another solution for this system could possibly be 1, 1. This is also included since it's over here in my shaded region, right in here, alright? Now we're going to take a look at another example where it's a little bit different. So I'm going to go back to my red since my first inequality is red. Now, with this we always need to remember our key concept. Step 1, let's graph both of these inequalities, alright? To graph this, I'm just going to again pick my y-intercept. I'm going to go up to my y-intercept and create a point. My slope is -2 over 3. So I'm going to go down 2 to the right 3 to get this system. Now we're going to ask ourselves, is it a dotted or shaded line? This is just a less than, so we know that we have a dotted line through these points. So we make our dashed line. Again, I'm doing on this on the computer, so mine's not going to be as perfect as I know all of yours is going to be. Alright? Next question. Are we going to shade below the line or above the line? Let's go ahead and test our point 0, 0. I plug 0 in for y, I get 0. I plug 0 in here, I get -2/3 times 0 is 0, plus 2 is 2. Inside here I have this sign. Is this a true statement? Is 0 less than 2? Yes, it is. So I'm going to shade everything below. And we make it nice and pretty with our shading. Look at that. Now I'm going to go ahead and switch to my green colored pencil. It's going to let me draw my equation green. I find my slope and I get, or my y-intercept first, sorry, and I get 4 as a y-intercept. Now my slope is right in here at -2/3 again, so I know I'm going down 2 to the right 3 again. Remember, rise over run, or the change in y over the change in x. So we're going down 2 to the right 3. I ask myself, is it a dotted or solid line? This one will be solid. Has that equal to right down here. When it has that extra line, we know it's a solid line. So I go ahead and draw my solid line as straight as I can go. Little not straight there. Sorry about that. Again, you guys will be using straight edges. Yours should be much straighter than mine. Don't use that as an excuse to draw crooked lines. Then I ask myself, what side of the line should I shade, right? Yes, you should be saying yes at this point. You should be listening to me. The point 0, 0, when we test it, we get 0 on this side is greater than or equal to -2/3 times 0 plus 4 gives me just 4. Is 0 greater than 4? No, that's not true. So I know that I'm shading above the line. Above this line. Yeah, shading, shading. Woohoo! Alright, we're shaded. Uh-oh. What do we notice about this one, guys? Notice how I have nothing crossing with the green and the red. This is a problem, right? Right. If they do not cross, if your shaded areas never coincide, never touch, then you need to keep in mind that answer of no solutions. Oh. It is pretty difficult to write with this thing. That's an O. This is an O. And this is an O. Apparently I'm having problems with O's today. No solutions for this problem. Now, don't think that just because our two slopes were exactly the same, making these lines parallel, that we had no solutions. You can't always assume that, because sometimes we'll have to shade inside here, and we'll get these all as solutions. Alright? Make sure that you graph both of these and that you're graphing them correctly, shading on the right side. It's very important if it's no solution or if you have these solutions inside these two lines. Alright? Or everything above one possible line. So make sure that you guys are checking that. Now, we're going to take a look at a third example that's just a little bit different, maybe a little bit more difficult. Alright? The first thing we're going to do, as in our key concept, is step 1, graph again. When I'm graphing this, we're going to look at the equation y is less than or equal to 3. So I'd graph it like it was y equals 3. Well, y equals 3 here. I've had a lot of people in my class trying to just make this the graph of y equals 3. But you need to keep in mind that y equals 3 is all along this horizontal line. Because it's a y equals, it is a horizontal line. Now, is it a solid line or a dotted line? Once again, we have a solid line with that equals to. So I draw my horizontal line right in here at y equals 3 with a solid line. Then I ask myself, is this line, or which side of the line do I shade? Alright, well, you can logic it out and say, well, we want everything less than that, or we can just test another point, which is what I'm going to do. I'm going to test the point 0, 0. I'm going to plug in 0 for y. I'm going to put this, and then I'm going to plug in 0 for x. There is no x, so I don't need to worry about it. We ask ourselves, is 0 less than or equal to 3? Yes, it is, so I know that I'm shading down in this region, down here. And I get this whole area. Alright? You're going to want to do your shading a little bit light just to make sure that you can see it all. Now, when I do this next one, I want to make sure that I recognize a few things. The first thing that we need to recognize is this is not just a line. This is an absolute value. We have these bars right here that let us know that it's an absolute value. And when we have an absolute value, we know we're dealing with a function that looks like a v. Absolute values always look like v's. Always, 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 forever. Always. And forever. Absolute values are v's. They're the only ones that are v's. They are not lines. If they have these bars, it is a v. So, we start with our normal parent function, which our vertex would be right here. Do I have any shrink stretch factor? Well, no, because this is just a 1 out here. Do I have any horizontal shift? Yes, I have this +4. But we don't listen to that +4, we do the opposite. So we're going to count over to -4, and this is where our vertex is, right here at -4, because I do not have any vertical shift. Alright, now, since our shrink stretch factor was just this 1, I know that I'm going to be going up 1 over 1, up 1 over 1, up 1 over 1. But then I need to ask myself, is this a line that goes down 1, back 1? No, we have that V shape. It is an absolute value, so we go up 1 to the left 1 also. Up 1 to the left 1 also. This is only for absolute value functions. Only when it has those bars. Now we ask ourselves one more time, is it a dotted or solid line? It's going to be dotted. Drawing my arrows on there because I know with these lines they go on forever. They do not stop. Alright, and now that I have this graphed, I'm going to go ahead and test yet another point. Well, let's choose 0, 0. Nice and simple, right? So I plug 0 in for y, and I get 0. Crazy enough. I plug 0 in for x, and I get 0 plus 4 is equal to 4. What's the absolute value of 4? Well, it's 4. 4 times 1 gives me a 4. So I keep my sign, I plug in my 4, and we ask ourselves, is this statement true? Is 0 greater than 4? No, it's not. So I know this point will not be included, which means the inside of my absolute value function is the part that I shade inside this graph. Now, I'm going to go ahead and switch to red so you guys can all see this. With the green one, I shaded below the line. With this absolute value, I shaded in between. So I'm going to get right in here is all of my solutions for this system of inequalities. Right in here, which means any one of these given points that is inside here will be a solution to both of these inequalities. To both of the inequalities. So, the next one that we're going to look at is a real-life example of the kind of situations in which you will actually use this type of material, because I know I got half of you out there saying, oh, when am I ever going to need to know this? When am I going to use it? This is this system that we are going to set up here is a perfect example. So, using the info in the ad, here's my ad, to write a system of inequalities for the regular footwear price and possible sales price. So the first thing that I'm going to need to do is go ahead and set up a few inequalities to understand this example better. I've gone ahead and just typed them in so you guys don't have to read my ugly handwriting, but I'm going to go ahead and explain them. Now, it says our x, which is our regular price, we want to be above 20. That's because the regular price up here needs to be between 20 and 80. So I know that my regular price needs to be below 80 also. What does that mean? That means that when I'm graphing these, I am only going to be concerned with these values, and I know that yellow is a little hard to see. I just want to kind of keep the colors involved. I'm only concerned with the values that run between these two lines. Alright? I'm only concerned with the values between them. That is where our sale is. Now I'm going to go back to red so we can see this first one. The way that I got this first one is because when we save 60%, we are only paying 40%, which means we're paying 40% of that regular price, that x value, okay? 0.4 is the decimal version of 40%. So we're actually only paying 40% because we're getting 60% off. We're saving that 60%. So to graph this, I know that my y-intercept is going to be 0. So I know I have this point to start at least. So now that I have this inequality, and I definitely want the values greater than that. I want the values greater than it because that is the highest, or that is the most that we can take off, which means this will be the lowest price that a person can pay. Alright? Now, when I think about this slope, instead of trying to do with decimals, I'm going to rewrite this as a fraction, which is 4 over 10. So I can go up 4, which is almost halfway, and over 10. Up 4, so I'm a little short still, over 10. Up 4 over 10. And I do this until I end up with my graph. And I know that when I go up 20, because I can multiply this by 5, multiply this by 5 without changing anything, and I can get 20 over 50 is moving it up and down the same amount. So when I do this, I need to ask myself, is a solid or dotted line? It has an equal to, so I know that this line is going to be solid. Now the next piece I need to ask myself, I almost jumped a step, is which side of this line do I shade? Well, I need to think about this one a little because I can't use 0, 0 because it's on my line this time. So we may need to try the point. Oh, I don't know. We can pick really anything. Let's pick 50, 30. Alright, we're going to plug in 50, 30. So my y value would be 30. I plug my x value in, which would be 50, and I get 50 times 0.4, or 50 times 4/10, which will give me 20. Now, is 30 greater than 20? Yes, it is. So I'm going to go ahead and shade everything above this line. Again, we're not really concerned with anything past these two yellow lines. Now we need to look at our next one, though. That blue function. Now, how did I get this function? Y is less than or equal to 0.9x. This one I got from my 10% that I saved, right? Because when I save 10%, I'm still paying 90% of that regular price, this x value, right? 90% written as a decimal is 0.9, or we get 9/10 again. So this time we're going to go ahead and take a look at it. We're going to graph our line. When we graph the line, we get our y-intercept as +0 again, so we're still at this point 0, 0. This time my slope, however, is 9/10. So I'm going to go up 9 over 10. Up 9 over 10. Up 9 over 10. If I multiply both of these by 5 again, this time I'm getting 45 over 50. And 45 over 50 puts me 45 and then up to 50. So I know for a fact I should be going through this point. It's just a little easier to find those when we multiply them. Again, I ask myself, is it a solid or a dotted line? We have the equal to, so I know I'm getting a solid line again. I really hope that your guys's are much straighter on your paper. But I get this line, this basic line, you know, much straighter again on yours. So, when I do this now, I should have gone over 50 up to 45. I'm sorry. It should be going through this point here. Don't worry about that one. This one is bad. Top one is bad. You guys are going to make mistakes sometimes. Alright? This is why you want to try and use like maybe colored pencils so you can erase it if you need to. Then we ask ourselves, it is a less than. We need to test our point. Let's test the point. Ooh, I don't know. Maybe let's try 50/30ths again. It is below that line, so let's try 50/30ths. When I put 30 in for y, or 50 and 30. When I put 30 in for y, I get 30 is less than or equal to, well, 0.9 times 50 would give me, that's the bell, so I need to finish this, would give me sorry, I'm drawing a blank here. 45. 45 is greater than 30, so I'm going to shade down here. That means that the price that anyone pays will be inside this line right here. Now, we're going to move to our next slide. Oh, make sure you remember the steps. Now it is your turn to try these problems. Please graph these system of inequalities and bring them with you to class. Thank you. You can pause it to write these down. Make sure you are bringing them to class. And as always, we want to make sure to thank our references, which is the book that we have in class, Algebra 2. Thank you guys, and I will see you in class. I'm trying to figure out how to end this show.